So in previous sections, we were looking at systems of equations, uh, such as 3x minus 4y equals -12, and then x minus 2y equals 10. Ooh, that's right. 5x minus 2y equals 10. So for the purpose of graphing, transform these into slope-intercept forms because they're easier to graph. So transforming the first one, we're going to get y equals 3/4 x plus 3. And I'm assuming that you guys know how to transform the slope-intercept form, so I'm not going to go through that. If not, you can go look back at sections. It's really just solving for y. And if this equation is solving for y, we get y equals 5/2 x minus 5. So then these equations can be thought of representing two different functions with the same independent variable. So y is put in terms of x in two different ways. So it's kind of like, for example, like if a newspaper carries expenses and incomes both depend on the number of papers he or she delivers, then x would be the number of papers she delivers, and both y's would be y would be either the expenses or the income. So the intersection point between those two functions would be when the expenses equals the income, and at which point they would break even. So let's say someone asks, what does y equal when x equals 4? We can't really answer this question because there's two different functions, because we're going to get two different y values for when x equals 4. So in order to distinguish between the two functions, we replace y with either f of x or g of x, or really any coefficient of x. So we're going to say f of x equals 3/4 x plus 3, and then g of x equals 5/2 x minus 5. And so, yeah, this f parentheses x is pronounced f of x, while g parentheses x is pronounced g of x. So now we can evaluate both functions at when x equals 4. So in the notation f of 4 would then represent 3/4 times 4 plus 3, while g of 4 would equal 5/2 times 4 plus 3. So basically all this is doing is it allows you to distinguish between multiple functions, and we can evaluate both functions when x equals 4 using this terminology. So one thing you want to be careful of is the notation f of x does not mean f times x. What the letter f is simply like the name of the function for the variable. So f of 4 is the value of the function at x equals 4, not f times 4. So for this example problem, we're going to go through and evaluate the different functions at these different points. So for part A, we have f of 5. So basically what this means is we're going to evaluate the function f at x equals 5. So we just substitute 5 in for wherever x is in the function f. So this will be 3 times 5 squared, which is going to equal 3 times 25, which is going to equal 25, or 75. For part B, we're going to be doing something similar, but now we're going to evaluate the function g at x equals 5. So this will be, we're just going to substitute 5 in for wherever we see x in the function g. So this will be 4 times 5 plus 1, which is going to equal 21. Oops, yeah, 21. For part C, we just have to do some division in the process. So we're going to have f of 2 over g of 2. So one thing that you should notice is you cannot cancel the 2's because these are not being multiplied. And what they're really saying is that these are just simply names for the values of the functions given at x equals 2. So we need to first substitute, plug in 2 for wherever x is in the function f, so that will be 3 times 2 squared over, and then we're going to substitute 2 in the function g, so it will be 4 times 2 plus 1. So this is going to be 3 times 2 squared, which is 3 times 4, so this will be 12 over, and then this will be 8 plus 1, which equals 9. Which is going to simplify to 4/3. Part D is what we call a composite function. So we have f of g of 6. So for these composite functions, we need to work from the outside in. So we're going to first find g of 6, and then whatever that value is, we're going to substitute that in for f. So we'll have f of, and then g of 6 is going to be 4 times 6 plus 1, which is going to equal f of, and then, whoops, that doesn't really work. So this is going to be f of, and then 4 times 6 is 24, plus 1 is 25. So this will be f of 25, at which point we'll just substitute that in for f. So this will equal 3 times 25 squared, which is going to equal 1,875. So for this next problem, we're going to suppose that your family is going to buy a new air conditioning unit. One brand costs $1,800 to buy and $60 a month to operate, while a more expensive brand costs $2,600 to buy, but is more efficient and costs only $50 to operate. So part A wants us to write the particular equations expressing f of x and g of x in terms of x. So the first thing that we're going to want to establish is that we're going to want to let x equal the number of months since you purchased the unit. The reason for that is that both of these products and their costs, which is what we're basically solving for, is going to depend on the amount of time since you purchased the unit. At that point, we're going to let f of x equal the total number of dollars spent in x months if you buy the cheaper unit. So I'm just going to write the amount of dollars for cheaper unit. And we're going to let g of x equal the total number of dollars spent in x months if you buy the more expensive unit. So I'm just going to write $sign for more for expensive unit. So for part A, we want to find f of x and g of x in terms of x. So let's go back to the original problem. F of x, which is the cheaper unit, costs $1,800 to buy. So you're going to spend $1,800 regardless of how many months you operate it. So running this equation, and since it costs $60 a month to run the cheaper unit, it's going to cost $60x to run it for x month. So the total cost for that cheaper unit is going to be written as f of x equals 60x plus 800. The $1,800 comes from the amount of the amount at original purchase, like at time 0 basically, like before you've been operating it, and then it's going to cost $60 additional per month. G of x, on the other hand, is just going to be the same it's going to be the same idea but for the other information. So this one costs $50 a month to operate plus the starting cost of $2,600. So part B wants us to find f of 100 and g of 100, and also what these relative costs of the two, what these numbers tell us about the relative cost between the two units after 100 months. So for f of 100, we're just going to, this is just the f of x notation. So basically, if we're going to find f of 100, and that is going to equal 60 times 100 plus 1800. Which is going to equal 800. And then for g of 100, we're just going to plug 100 in for the g of x equation. So it's going to be 50 times 100 plus 2600, which equals 7600. So this tells us that after 100 months, the more expensive unit ends up costing less money because it costs less money to maintenance. So I've drawn a sketch of f of x and g on the same axis, and as you can see, though f has a smaller initial cost, its price is actually increasing at a faster rate than g, which has a higher initial cost but slows down quite or grows at a much slower rate. Now at this point is when f of x equals g of x, and this is the point at which at some time x months they're going to have the same cost. In solving the system of equations, we'll find that break-even point, as we'll do in the next part. So it wants us to solve the system of equations that we found in part A and to find the break-even point. That is, find the number of months for which the total costs of either unit would be the same. So, going back to our original functions, which are f of x equals 60x plus 1800 and g of x equals 50x plus 2600, f and g stand for actual values of price, while x stands for the amount of time since the time of purchase. So to find the time when the value of both units are going to be the same, we're going to want to set f of x equal to g of x. At this point, we can just set the two equations equal to each other and then solve for x. So to do this, we're just going to move the 50x over along with the 1800 over, and we'll get 10x equals 800. And then dividing by 10, we get x equals 80. So what this means is at 80 months from the original purchase, the two units will be worth this. Well, you will have paid the same amount for both units.